Welcome to Lesson 9. This is the last lesson in the Basic Server Management Tasks section. In this lesson you'll learn how to set up and manage networking. We'll first go through setting up local network interfaces. This includes network naming as well as working with the IP tool. Next, you will learn how to use Network Manager and associated tools to create a more permanent network configuration. You will also find an important part about troubleshooting network connections in this lesson and learn how to use the essential tools that are available to analyze a problem and fix it if something is not right. At the end of this lesson, you'll find an exercise that reviews all of the essential network management skills. So to set up networking, you should first understand about network interface card naming. In previous versions of Linux, network interface card naming was simple. Your NIC was just called ETH0. In RHEL 7, there are 3 different naming schemes that are available. So first there is BIOS naming, which is based on hardware properties of the network card. Typically you would see network card names like EM1 up to anything for embedded NICs. EM is just short for embedded. Or you could find names like P followed by a slot number, P followed by a port number, for example P6, P1, which is PCI slot 6 and port number 1 on that slot. Then there is UDEF naming. UDEF naming is the classical naming that is ETH0, ETH1 and so on. And then there is also the physical naming, which is the same as BIOS naming. These 3 naming schemes are existing in Red Hat Enterprise Linux 7 just to make it easier to identify network cards. I mean, in older versions of Red Hat, especially if a server had multiple network cards, let's say ETH0 up to 3, it could be very hard to identify which physical network card relates to which network interface. And the network device naming, as it is applied in Red Hat 7, makes working with specific network cards a bit easier. Then we also have logical naming. Logical naming is the naming that you use in VLAN and in alias configurations. We are not covering that in this course, but I just wanted to be complete, and that's why I included it on the slide.
In this lesson, I will show you how to work with the IP command to manage network interfaces. You should notice that when using the IP command, everything will be gone once you reset the interface. But the IP command is a very useful command for system administrators because it allows you to test certain settings on network cards. In the past, the ifconfig command was used to do the tasks that I'm about to explain here, but ifconfig shouldn't be used anymore. I will also explain why ifconfig shouldn't be used anymore. Now, people that see the IP command for the first time, well, they tend to be a little bit overwhelmed because it's not a really easy command to use. And that is because the IP command works with subcommands. Let me show you IP help, which gives some information how the IP command is used. So the basic usage is IP followed by some optional options, followed by an object. The object is a subcommand and all the available objects are listed here. Now there are only a few objects that we are interested in for this course, and that is link, which gives you network status information, ADDR, which allows you to set network addresses, and route, which helps you managing the routing table on your system. Now, following the object, we have a command, or you can use help to get more information about a specific command. So for instance, you can type IP ADDR help to get help about using the IP ADDR command. Now let me start by doing IP link show. IP link show is showing me the network interfaces that we've got. So there's LO, which is loopback, and there is ENS33, which is the embedded network card on this machine. Based on that information, we now know that we have an ENS33 and we can see the current state of network interfaces. Now let me type IP-ADDR show, which shows the current address information. As you can see on both loopback and the Ethernet network card, we have an IPv4 network address and we have an IPv6 network address. IPv6 still isn't very important in RHCSA, so I'm going to ignore IPv6 for the rest of this discussion. Now that we are talking about the show options, let's do an IP route show as well, which is showing the current routing table. So we have a default route which is sending everything to the IP address 192.168.4.2, which allows us to send packets over to the internet. If we want to change or add or whatever network addresses, we do that using IP-ADDR as well. The command would be IP-ADDR add followed by the name of the device, which would be ENS33, followed by the IP address we want to add. I just want to show you how to add an IP address, so I'm not going to make it very complicated here and type IP-ADDR add dev ENS33. IP-ADDR add, which is add an address to the device with the name ENS33. So which should be the address? Well, let's take 10.0.0.10/24 for example. When using IP-ADDR, you always want to use an address followed by the subnet mask, because if you don't specify the subnet mask, well, you will get a subnet mask of 32, which doesn't really make sense. To see if we succeeded, we can use IP-ADDR show, which shows us that the 10 address has been successfully added to the network interface. Now let's do ifconfig, because some of you will be used to using ifconfig to manage network interfaces, and as you can see, we do see the first IP address, but ifconfig has no capability of showing the second IP address, and that's also not going to happen if you type ifconfig-a. And I know this is shocking for some people that do like ifconfig so much, but the man page of ifconfig is explaining it. Well, look at this. This program is obsolete. For replacement, check IP-ADDR and IP-link. So ifconfig has been obsolete since the launch of Linux 2.0 kernels, which was back in 1996. Yes, that is about 20 years ago. But I know on some Unix operating systems or on Mac OS, ifconfig is still the only way to manipulate IP addresses on network cards. Don't do that anymore on Linux, please, because you will miss some information. By the way, it also mentions some other interesting information, which is IP-S link. Let's have a look at that. IP-S link, which is showing statistics. These are the statistics that many people like a lot being displayed with the ifconfig command. Now there's one more thing that you need to be able to do from the command line, and that is routing. So IP route show shows the current routing. If you want to add a route, you can do that as well. IP route add followed by the network you want to add a route to. Now there is no 20 network, but I just want to show you how it works. So IP route add 20.0.0/8 specifies the network that I want to add the routes to, and next I use via followed by an IP address, which always has to be on the local network to define the route. An IP route show is going to show me everything. Now using the IP command is good, but it will live only until you restart your machine. So at the moment that you reboot, everything will be gone here. And that is why you need to make sure that the information is stored in the appropriate configuration files, which I will explain in the next lesson. You have just learned how to use the IP command to set network information on a temporary basis. That is not what you want on a server. On a server you need fixed solutions. And that's what we're going to talk about right now. So to start with, there's a nice GUI interface that helps you setting the information you need. If you right click it, you can switch on or off the network interfaces on your server, and you can select network settings. So what you can see here is the wired interface, and you can see the current IP configuration. And if you click here, you get access to an interface where you can specify the IP information that you need. Now, before diving into the configuration files, I want to make a real configuration, so I'm switching this to manual, which allows me to type a manual IP address, which is the most typical solution for servers anyway. So I'm going to use 192.168.4.44 with a net mask of 24 bits and a gateway of 192.168.4.2. Of course, you should verify what exactly you need to use in your environment. Next, there's the DNS information. Let's use Google DNS. And if you want to, you can specify alternative routes as well. I don't want to do that. This is good enough for me. So once I'm happy, I can apply to save the configuration. So once I've applied it, I can find everything in a configuration file, which is in etc sysconfig network scripts. In this directory you can see that a configuration file exists for every single interface. Now I have one interface only, so what I need is the file efcfg-ens33. And you can see that all the configuration is written in here. So let's go over the lines of configuration that we see here. So the type is Ethernet, which is pretty basic. The boot proto is the boot protocol, which is set to none. If you want to use DHCP, you can change it here and set it to DHCP manually. Dev route and IPv4 and all this is not very important. The next important parameter is name equals, which is the name of the network interface. Then we have onboot equals yes, which specifies that the network cards should be switched on while booting. Then we have the HW address, which is the MAC address of the network interface. We have the IP address, the prefix and the gateway. Now look at this, we have IP-ADDR0, which means you can also use IP-ADDR 1, 2, 3 and whatever you want to use to specify more than one IP address on one interface. And there's a prefix associated and there's a gateway associated with it as well. Then we have the DNS server, which surprisingly starts with DNS1, and we have some other settings that don't really matter. And this is where basically the network configuration is written to. There's one thing that you still need to know about, and that is the host name. So in the etc directory there is a file with the name hostname, which contains the host name of your server. Now if you are used to previous versions of Red Hat Enterprise Linux, this is a change, because finally Red Hat is using what everyone else is using, the file etc hostname, and previously this information was in etc sysconfig network. Now what you should know is that one other important file isn't used anymore. So let's have a look at the resolve.conf file that many system administrators will look at anyway. What you can see here, it is generated by Network Manager. As I will explain in the next lesson, Network Manager is the most important part of the system that takes care of network configuration. And Network Manager reads the file in the etc sysconfig directory that we've just seen, and it pushes the configuration to this file. So don't change it here, because it will mess up the working of Network Manager.
In Red Hat Enterprise Linux 7, Network Manager is the part of the operating system that takes care of managing the network cards. Network Manager is a little bit difficult to understand, and that is why I created a slide that should make it clear what exactly you are doing. So what we can see here is that there's a network card, the physical network card. And there are three different ways of changing the configuration on the network card. There's the IP command, there is the nmcli command, and there is the Network Manager text user interface. So what is happening, if you are using IP add, for example, you are adding an IP address directly to the physical network card, which means that the physical network card can start using it immediately, but this information is not managed by any service, which means that at the moment that you would restart your computer, the information is gone. And even if you bring down the network interface and bring it up again, the information is gone. And that is why you want to store the information in a script which is in etc sysconfig network script ifcfg-ens33, for example. So if you are using either the nmcli or the text user interface, you would write to the Network Manager service. And the Network Manager service writes it to the script, and as it is written to the script, whenever your network card is restarted or your server reboots, the information just reappears at the moment that it comes up again. So this is a much better way of managing network configuration. You would use the IP command for temporary changes only, and you would use the Network Manager commands for permanent changes.
There are two utilities that are related to Network Manager. The first of them is nmcli, which is a command line interface. I'm just typing nmcli to give you an overview of everything that the command can do. Now the nmcli utility works with objects, which are like subcommands. It's more or less like the IP command that also works with objects. The most important object that is used with nmcli is a connection. In order to use the utilities for Network Manager, it is very essential that you understand what a connection is. So by default we have network interfaces. A network interface is just an interface with some configuration associated to it. Now a connection is an abstract layer on top of a network interface. The idea is that every network interface has a default connection, but you can easily add a testing connection as well. And with the Network Manager utilities you can then switch between connections. So let me show you a little bit how the Network Manager command line interface works. First command I'm typing is nmcli connection show. Please do remember you always need these objects when working with nmcli. So we can see that we have a connection with the name ENS33, a UUID, a type specification, and a device that is in that connection. Now I'm already in the network scripts directory, and if we do an ls there, we can see that there's also a matching ifcfg-ens33. Now let me use the command to add a new connection. It's not an easy command, and also the documentation in the man page is incorrect. So look carefully. So what I'm doing, nmcli con, which is short for connection, add. And then we need con name to specify that the thing that is coming now is a connection name. So let's use the connection name testing. IF name ENS33, because still it is very important that you define the interfaces that are within a connection. Type Ethernet IPv4. This is where the man page is wrong, because the man page says it's IPv4. IPv4 is not gonna work, it is IP4. And then I'm typing 10.0.0 15/24, for example. And you can see that the connection has been successfully added. When I type nm CLI connection show now, we can see that there are two connections available. And when I type ls in the network scripts directory, you can see that a separate script has been created for the connection I have just added. Now it is relatively easy to switch between connections. That is also nm CLI gone down ENS33, for example, to bring down the default connection. Please notice that you do need the name of the connection as it is shown with nm CLI con show. So ENS33 is what we need here. And then I do nm CLI con up testing to activate the testing connection. And if I do an IP ADDR show now to see the real configuration that is used at this moment, we can see that 10.0.0.15 is the active IP address. Now, is there anything that we can see in the IFCFG testing configuration script? So it is just the configuration as it is used right now with an onboot equals yes, and if you do the same for the IFCFG ENS33, you can see that it's more or less similar. You can also see that there are some little differences. These little differences between the configuration scripts is always something that you can put in manually. So basically the nm CLI command is an interface that allows you to put configuration in new configuration files. And this is the way it works. Now if you don't like nm CLI, which I can imagine, there are other nm utilities as well. Like nm TUI, which is the text user interface. So as you can see, the NMTUI is also a connection oriented utility. So let's do edit a connection, and you can see the connections that are existing on this system. So there's a testing connection and there's the ENS connection. And if you do edit on one of the connections, well, it tells you the profile name, which is the connection name, by the way. And then we've got the device name and the IP configuration that is associated. So I didn't put in a gateway using nm CLI. You can do that with nm CLI, but it makes a command even longer. So I'm not sure that this is what you want to do. So let's put in a gateway like 10.0.0.1 and DNS servers, and well, whatever configuration you want to put in, you can put it in here. And if you're happy with it, just click OK. And then we have the other connection as well. And yeah, you can just manage all the connections in whatever way you want them to be managed. So let's do an OK, and let's do a quit. And up to now I have managed connections only. These connections are by themselves managed by Network Manager. So what if we do system ctl restart Network Manager? Wow, that was fast. Let's do a status on Network Manager as well. And you can see that the Network Manager service is active right now. And you can see that it is working on the ENS33 device, so that all looks good. But it doesn't really give us connection information. So when I do an IPA right now, you can see what happens. And that is that both connections are active. So if you don't want your testing connection to come up at the moment you restart the Network Manager, you should make sure that either via the nm CLI command or via the scripts that the connection is disabled and not set to appear automatically. And that is how nm CLI and nm TUI can be used to manage connections.
So when setting up networking, routing in DNS is very important. And I want to explain a little bit what routing and DNS actually are doing and what is important. So in here we have a diagram of two different networks. And let's say this computer, that's me. And I want to go out on the internet. Now, in order to go out on the internet, my computer needs to know how it can get out of the internet. And that would be the setting of the default route. Now, the default route normally is always an IP address that is on the same network as yourself. So the default route is helping you to get out of the network where you currently are at. So in this case, 192.168.1.1 would be the default route, because this is the computer that is connecting to another network. And from the other network, there is another computer that is connecting to the internet. But I don't care about this IP address, because the only thing my computer cares about is how to get packets out of the local network. So my computer, based on the default routing setting, could give it to this computer. And next, this computer would read the packet and would see, hey, this is a packet that has to go to the internet. And in order to do that, this computer needs a default route as well. And you probably can guess it already, that would be 10.0.0.1. So this computer would send the packet over here, and next, the computer here, well, by itself, it also has a default route that connects to the internet. And there we go. By using all of those default routes, the packet can get sent to the internet. Now, another interesting example of routing is if we are here. Let's say this is you, and you want to send me a packet. Well, what is going to happen here is basically this. So the packet needs to go to this computer first, and then can be sent to my computer. But we have a dilemma here, because on your computer, probably you also want to send packets to the internet, which is a packet flow that goes like this. So on your computer, you would need two different routers. The first one is the default router, and the default router would be the IP address of the computer that's going out to the internet. But you would also need a specific route that tells your computer how it can reach the 192.168.1.0 network address. And that would be 10.0.0.10. So in some cases it is necessary to configure a computer with more than one router. But on most cases, just a default router is good enough. Now there's a second part of configuration that is very important for computers, and that is DNS. So what is DNS? Well, imagine that you want to go to a server like server.rheadcert.com, which is the classroom server that we are using in this course. Now this is a name, and computers don't communicate with names, they use IP addresses. So in order to use the server back there on the internet, we need something to translate the server name into an IP address. And that is exactly what DNS is doing. So DNS can be anywhere, can be somewhere on the internet, or it doesn't really matter. But the thing that does matter is that every computer that needs to be capable of using names like these needs to be configured with a DNS server. And this is basically everything you need to know to hook up your computer to connect with anyone else on the internet.
Now let's apply routing and DNS settings. If you want to apply them on a temporary basis, there is IP route, of course. IP route show is showing you the default router that we've currently got. And if I want to add some routes to that, I can use IP route add, followed by the name of the network I want to add the route to. I don't want to mess up my default route, so I'm just adding 10.0.1.0/24, for example. And next we need the address we want this route to pass through, so that could be 4.3. IP route show is telling me that all works fine. Now I don't even have to try this because I don't have a 10.0.1 network somewhere, but if you would have it somewhere, you can now ping and check that it all works out well. So once you've verified your routing, you need to make it permanent. The only thing you need to be able to do for the RHCSA command is to change the default route, which is in etc sysconfig network-scripts ifcfg followed by the name of your NMCLI network connection. So you can see it here, gateway equals followed by the IP address of the gateway, and that is all you need. Change it here and it will work out well. And after changing it here, don't forget to do an NMCLI con down ENS33 followed by an NMCLI con up ENS33. That will activate it. It will even survive an SSH connection because it's pretty fast. So the next thing you need to configure is DNS. DNS is name resolution, and typically what you want to be using first is the DNS server of your internet provider. In DNS you can use multiple DNS servers. The default is that only if the first DNS server cannot be contacted, the second, third and so on DNS servers will be contacted. So for redundancy purposes, you should at least include 2 DNS servers. And you would also do that in the configuration file for your network connection. We can see here that I already have a DNS1 equals with an IP address and a DNS2 equals with another IP address, which is fine. DNS doesn't work in a way that the second DNS server is contacted if the first DNS server didn't give you the right answer, because all DNS servers are supposed to be perfect and to give you the right answer anyway. So this is good. Put it in the configuration file for your network connection and you'll be all good. And that's all.
If you have a problem with the network, there's a couple of utilities that is available. Before showing you how to use them, I want to give you a short overview of these utilities. So first, there's the hostname utility. The hostname utility is just a very simple utility that you can use to check your own hostname. Then there's the ping utility. Ping is a connectivity check. If you want to know if another computer can be reached, use ping. Then there's traceroute. If you want specific information about routing between your computer and a destination computer, traceroute will give you that information. You should be aware though that traceroute doesn't work that good nowadays, and that is because many routers are configured not to display any information about what they are doing. And that means that traceroute is just going to show you, well, nothing at all. Then there's dig, a very useful utility that is showing you DNS information and that you can use to identify problems that are related to the DNS system. Then we have Nmap. I like Nmap a lot because it's an advanced utility with many possibilities, but it's also a dangerous utility. It can give you information about remote service availability. What you should know about Nmap is that by many network administrators or providers, it is considered a hostile utility because hackers can use it as well to do a port scan and see which services are offered by specific servers. So if you are using Nmap, do it on your own network only and don't do it on servers on the internet because you might get in trouble with your internet provider if you do. And then we have Netstat. Netstat can be used for multiple purposes. There is, for example, Netstat-I, which shows packet information for network cards, and there's Netstat-Tulpen, which is showing you information about listening ports. T stands for TCP, U for UDP, L for listening, P for process information, E for extended information, and N is giving you names. So that makes a nice word, tulpen, which by the way is tulips in my native language, Dutch.
There are a couple of commands that you can use to do troubleshooting of network connections. So if your network isn't working, the first thing to do is to check your current configuration and compare it to the documentation. You do have documentation, don't you? So IP-addr show will be a part of that, which is showing me that I have 192.168.444 IP address, which is the one I need. Next you would do IP route show and make sure that you have a default route, and the default route is going via something that is in the same IP network as your own primary IP address, or whatever IP address, by the way, it doesn't really matter. So you can see that we go through 192.168.4.2, which is good. And next you need to check DNS name resolution. Still, the best way to check that is the file resolve.conf. Even if it's not the typical place where you want to manage DNS servers anymore, you still can see the default configuration in here. So this all looks good, and if the connection still doesn't work, well, you need to do some additional testing. When I need to do testing, the first thing I'm doing is ping. Ping just tests connectivity to whatever IP address on the network. So a nice start to ping is the default router. I'm using, by the way, -C1 here, which stands for count one packet only. And it is pinging the default router, which is at 4.2. So I get a reply, so this all looks good. I like starting my ping tests by pinging the default router because it's the very first machine you need to get out on the internet. You can of course start pinging something on the internet directly as well, but if it does reply, well, it tells you that all's good, but if it doesn't reply, it doesn't tell you where the problem is. In this case, we can see that it does reply, so all is fine. Well, there's also a nice command. Well, this is more bandwidth troubleshooting, but since we are talking about ping, I want to show you anyway. It's the ping -f, which is a ping flood. So I've been running this for about 2 seconds, and you can see it has sent over 3000 packets to the destination IP address. This is not your typical connectivity test, but if you do need to do a bandwidth test, this is very useful. But don't normally include it in your connectivity troubleshooting procedures. There are some other commands that help you test network connections as well, and one of them is trace route. Well, once it was a very nice command, but nowadays, well, let's have a look how it behaves on 8888. So what it is doing, it is trying to reach the ultimate destination. And for every router that it crosses between your computer and the ultimate destination, it displays the IP address of the router and the time it took. But if on the router some filtering is applied, you will see star, 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 like is happening here. This doesn't really give you any good information, so let's Control-C it. Next there's another nice command, which is host. So let's do host on ldap.rheadcertification.com, and it gives me the IP address of the host. So this is just a very quick test to see if host name resolution does work. A more interesting test is dig, which gives you more in-depth information about the DNS name lookup process. There's a difference between host and dig. Host is checking the host resolution mechanism, and dig is checking DNS and nothing else, which means that host will give you a result if the host is in a local configuration file like etc host and dig doesn't. So dig is giving us a lot of information. Now let's have a look at what exactly it is giving us. First and foremost, there is no error. So the result is good and we've been able to do hostname resolution. Then it tells me that the question was for ldap.rhatcertification.com and we wanted an address for that one. And the answer was for, well, this host, and we got an address which is 213 and so on. And the server that was queried was 8.8.8.8, so apparently that is the Google name server. And that is because I'm using Google as my name server. Now, if you wanted to do a little bit of performance optimization, it doesn't always make sense to go out to Google because rhatcertification.com is just next door. And I'm going all over the world to contact Google name servers in order to get my answer. That's not really nice. So let's do a quick fix and change that through etc sysconfig network -scripts. We have the ifcfg ENS 33 and that has the DNS name server. And I'm just making the Google name server number 2 in the list, and the primary name server, well, that's going to be my local name server of my internet provider. That makes a little bit more sense because it's much more nearby. Let me do a systemctl restart network manager to reactivate, and let's see if that worked out well. I'm doing dig again, and oh dear, do we have a problem here? It could be, it takes too long. And if a dig request like this takes long, then, well, normally no service could be reached. Hey, now watch out, I have just made a modification. And I have included the IP address of my internet provider, and after restarting the network I get a no service could be reached. That's not normal. So let's try to ping it. That doesn't work. So this looks like restarting my network configuration didn't work out well. So let me do IP-addr show to verify that all looks good. And what we've got here is, well, the IP configuration looking good. Let me do an IP route show. Do we still have routing? Do you see that? We have a default route that is going through 10.0.0.1. And that is not really what I would like to do. So we need to do a little bit of cleanup. So do you remember the part about NMCLI where I created some additional connections? It's probably the additional connection that is annoying me here. So I'm going to etc sysconfig network scripts, and I can see my ifcfg-testing connection. So let's have a quick look in that. Oops. And you can see that it has a gateway of 10.0.0.1, and that is bad. And you know what? I don't need my ifcfg testing connection anymore, so let me do an nmcli con down on testing. The name of the connection was testing, so I can just use testing here to bring the connection down. And if I do IP route show now, then we can see that now the default is good. So apparently the ENS33 connection was loaded first, and after that the testing connection was loaded, and both had a default route that was specified, and the testing connection like overruled the default route. Which teaches us that you should be careful about the way that you are applying routes if you're working with multiple connections. Now we were digging, so let me do the exclamation mark DI to repeat the last dig command, and what we can see here is that again we've got no error, and the server this time is 212.45.35.24. Now the next thing I would like to do is to dig something that doesn't exist. blah.rheadcertification.com. So blah is a hostname that doesn't exist in a domain that does exist. The answer that Dig is giving me is NX domain. NX domain means no such domain. So the question was for an IP address for this host, and we got an answer. And let's have a look who gave the answer. That is in the authority section. In the authority section we've seen that we wanted rheadcertification.com, and this is the name server that has been replying to us, and it is the SOA, which is the start of authority. So this is a very reliable name server that is responsible for this domain, which is telling me NX domain, which basically means, hey sender, you are stupid, this domain doesn't exist. Let's do it in another way. Whatever.com. This is also an NX domain, and you can see the authority section in this scenario was in com. So since the com name server has been contacted and the com name server tells me, hey, I can't work with this, the problem is probably in here. And if you make the top level domain as an unknown domain as well, well, you can guess what is happening. It's the root name server that is replying me and telling me no such domain. So NX domain is a useful piece of information, but when you get an NX domain, you should always check where it comes from. And this basically concludes this part about network troubleshooting tools. So the troubleshooting tools resumed. There is IP. IP ADDR to show the address, IP route to show routing. There is ping, which is a useful command. There is host, there is dig, and if you still believe in fairy tales, you can use traceroute as well. I'm fine, but I don't think it is very reliable utility because of filtering on the routers. There's one more thing I'd like to show you, and that is IP-S link, which is giving you statistics for all the links in your network. Because on some cases your problem might be a configuration problem, it might also be a physical problem. And if it is a physical problem, IP-S link is giving you useful information. The RX bytes is the received bytes, TX bytes is the transmitted bytes. You can see the number of packets and the errors or dropped or overrun or collisions or multicast that has been received on this interface. You can also see that the state is up, and this all looks good. In some cases, if you do have a physical problem, you may see errors occurring here, which is a useful indication for troubleshooting.
So we have learned a lot in this lesson. Let's have a look at the exercise. In the exercise, I would like you to set up your network interface to use the following configuration. And you must make sure to apply the configuration persistently. So use an IP address of 10.00.29/24. Specify a router of 10.00.254. And I don't care if that IP address doesn't exist in your environment. I just want you to be able to set the information. You don't need to make it working in the exercise. You just need to apply the skill of how to change all this information. Likewise for the DNS server, which you can also set to 10.00.254. And then you need to change your hostname to server 29. Very important, after doing all this, you need to verify that the configuration works. So use the appropriate utilities to check that all the configuration has been properly set. And after verifying, you need to restore the original network settings to use DHCP or whatever you were using to get outside on the internet. Because if you don't, all the other exercises that need a working network and that are covered later in this course won't work anymore. So make sure to restore the original configuration.
So exercise 9 is an interesting exercise. The thing is that you should consider how you want to do an exercise like this on the exam if you get it there. Well, the answer is do it as easy as you can. Because I mean, you can use NMCLI to change IP address, router, and so on. You can use configuration files to change all that, but you can also use an easy to use utility like NM-TUI or even the graphical interface that we've got in the upper corner of the desktop. I would prefer NM-TUI because it's a text user interface and it's easy enough to use. And you can see here set system hostname, which allows us to change the system hostname. Just remove this and type the new hostname and then you'll be all good. So that would be server29.example.com. It asks us if we want to set it, and yes, it is okay. But hey, you still have the old host name here, but that is normal. That is because it's a shell variable, and that will only be reset at the moment I start a new shell. So once you've configured this host name, you can get back in the NM-TUI to edit the network connection. So it's the ENS33 connection I need here, and to change the IP address, I would do that here. So that would be 10.0.0.29, and the gateway needs to be changed accordingly to 10.0.0.254, and the DNS server is supposed to be 10.0.0.254 as well. And are we missing something? Yes, of course, we are missing the subnet mask. Did you notice what it has done to the subnet mask? Because I didn't specify anything. It used /32. I don't want it. I want /24. And then I do OK. And I do quit to save the configuration. Now let me show IPAS for IP address show to see what we've currently got, and what we have is still the old configuration. So in order to activate it, I need to restart the network interface. So that would be NMCLI connection. Now let's just do con, that's easy enough. Con down on ENS33 and NMCLI con up on ENS33. And a new configuration has been active. Apparently I've been messing up something, because when I wanted to bring it down it complained that it wasn't an active connection, but now we can see that the new configuration is up and running again. So this all works except for the host name, but the host name will take only after a restart or after closing all shells on your server. Since the hostname variable is pretty deep in a server, I would really recommend to restart the server instead of just closing and opening a new shell. At the end of this exercise, get back to NM-TUI and edit the connection again, and make sure that your IP address configuration is set to automatic. You can remove all the configuration that you entered manually, and you can just do an OK to save it to the configuration file. Next you need to bring down and up the interface again, and the DHCP server will get out there and will get you some IP address related information. You can see that here I now have an IP address 4.141, and I should also have it in resolve.conf. Now, this is very important because if you don't do this, you will mess up all other exercises in this lesson. So do make sure you restore the original configuration. And that's it.
And that brings us to the end of the lesson about networking. And what can I say about it? You've learned everything you need to know about setting up a network. And you can imagine that this is a core skill on the R8CSA exam. Imagine that you get a server that is not properly configured to connect to the network and you don't know how to connect it to the network. You will be in big trouble if that happens. So make sure that you understand everything that has been covered in this chapter.